Between the galaxies, there is something we can barely see. It is not another galaxy. It is not a black hole. And it is not empty space. Astronomers have found enormous numbers of stars drifting freely through galaxy clusters, no longer belonging to any individual galaxy. Their combined light creates an incredibly faint glow between the galaxies. And now, observations from the James Webb Space Telescope are showing that this ghostly light may be telling us something about something we cannot see at all. Dark matter. The strange part is that the stars are visible. The thing they may be tracing is not. To understand what is happening, we have to look at one of the most violent environments in the universe, a galaxy cluster. A galaxy is already enormous. But a galaxy cluster is something else entirely. It can contain hundreds or even thousands of galaxies, all bound together by gravity. The space between those galaxies may look completely black. But gravitationally, it is anything but empty. There is hot gas. There is dark matter. And there are stars that have been torn away from the galaxies where they were born. These are sometimes called intracluster stars. They are effectively cosmic orphans. A star can spend billions of years inside a galaxy, orbiting peacefully with millions or billions of other stars. But galaxies do not always remain peaceful. When they pass close to one another, their gravity can pull on their outer regions. During mergers and close encounters, entire streams of stars can be stripped away. Those stars do not necessarily disappear. They continue orbiting. Only now, they orbit the gravitational center of the entire cluster rather than a single galaxy. And because there can be enormous numbers of them, their combined light creates something remarkable. A faint, diffuse glow spread through the space between galaxies. Astronomers call it intracluster light. The problem is that it is extraordinarily difficult to detect. Individual galaxies are bright. Stars inside them are packed together. The light between galaxies is spread over a huge area, making it extremely faint. It is like trying to detect the glow of a single candle after someone has switched on thousands of floodlights around it. But this faint glow contains a clue. The stars producing it are no longer controlled by individual galaxies. They are moving through the gravitational field of the entire cluster. And that makes their distribution potentially useful. Because there is another component following the same gravitational field. Dark matter. We cannot see dark matter directly. It does not emit, reflect, or absorb light in the ordinary way. We know it is there because gravity reveals its presence. It helps hold galaxies together. It shapes galaxy clusters. And it bends the paths of light passing through space. But for decades, astronomers have faced the same frustrating problem. How do you map something that does not shine? One of the most powerful answers is gravitational lensing. If enough mass lies between us and a distant galaxy, gravity can slightly distort the light from that background galaxy. The distortion may be tiny. But measure thousands of background galaxies, and a pattern begins to emerge. From those distortions, astronomers can reconstruct where the invisible mass must be. And this is where the strange light between galaxies becomes important. In 2025, researchers used Webb to study the Bullet Cluster, one of the most famous galaxy cluster collisions ever observed. The Bullet Cluster is actually two enormous galaxy clusters that have collided. The event is so energetic that their hot gas was separated from much of their dark matter and galaxies. That separation has made the system an important laboratory for studying dark matter. Webb provided extremely detailed near-infrared observations of the cluster. Researchers were able to identify thousands of background galaxies for gravitational lensing measurements. But they also measured something much fainter: the light from stars wandering between the galaxies. And here came the important result. The distribution of this intra-cluster light followed the overall gravitational structure of the cluster closely enough to act as a useful tracer of its dark matter. For something we cannot see, that is an extraordinary indirect signature. The stars are visible. Dark matter is not. But both are responding to the same enormous gravitational landscape. It is almost as if the invisible structure is leaving a faint outline in starlight. But there is a catch. And this is where the story becomes more interesting. Intracluster light is not a perfect map of dark matter. Recent theoretical work shows that these orphan stars can be distributed somewhat differently from the dark matter itself. Their orbits and energies are not identical. So astronomers cannot simply look at the faint glow and say, there is the dark matter. The relationship is more subtle. The light can trace the structure. But it must be calibrated and interpreted carefully. That distinction matters. Because astronomy often works this way. We do not see everything directly. We see effects. Then we build models to explain those effects. And sometimes the model works beautifully. Other times, a new observation exposes the places where it breaks. The bullet cluster is especially valuable because it gives astronomers several independent things to compare. There are the galaxies. There is the hot gas, visible in X-rays. There is the faint intracluster light. And there is the distribution of dark matter inferred through gravitational lensing. These components do not behave identically. During the collision, the hot gas interacted strongly and was slowed down. The galaxies passed through much more easily. The dark matter remained aligned with the galaxies within the precision of the observations. And the faint stars between galaxies provide another way to study the gravitational structure. Put all of these clues together, and the cluster becomes something like a cosmic crime scene. The collision happened billions of years ago. We cannot watch it unfold. But the matter left behind tells us what happened. And there is something especially strange about the orphan stars. They are not just debris. They may become a long-lasting component of the cluster itself. Some stars that were once part of galaxies can spend the rest of their lives wandering through intergalactic space. Eventually, their combined light can become a permanent feature of the cluster. So when we look between the galaxies, we may actually be seeing the aftermath of ancient galactic violence. But the story goes even deeper. The stars are made of ordinary matter. Hydrogen. Helium. Heavier elements forged inside previous generations of stars. Their light can tell astronomers about the history of the galaxies that lost them. The colors and ages of these stars can reveal when galaxies interacted and how their structures changed. In other words, the space between galaxies may contain an archive of events that galaxies themselves no longer remember. And Webb is making that archive easier to study. Its infrared vision is particularly useful for detecting faint, distant sources and separating them from the brighter structures around them. But Webb is not discovering a mysterious new substance between galaxies. The intracluster stars were known before Webb. The strange part is what they allow astronomers to investigate. A population of stars that looks almost insignificant can become a probe of the largest invisible structure in the cluster. Dark matter. And that brings us to the biggest unanswered question. What exactly is dark matter? We still do not know. The observations tell us that there is additional mass influencing the motion of galaxies and bending light. The leading explanation is some form of matter that interacts weakly with light but strongly enough through gravity to shape cosmic structure. But its fundamental nature remains unknown. Is it a new particle? More than one kind of particle? Something even more complicated? The intracluster light cannot answer that question by itself. But it can help astronomers test how dark matter is distributed. And when combined with gravitational lensing, X-ray observations, simulations, and other measurements, it gives scientists another way to challenge their models. That is why the faint glow between galaxies matters. The universe may look empty between its great islands of stars. But it isn't. There are stars drifting through the darkness. There is hot plasma. There are enormous gravitational fields. And beneath it all may be a vast invisible structure that holds the cosmic architecture together. The strangest part is that the thing we can see may be useful precisely because it has been separated from the galaxies. Those orphan stars are not merely leftovers from ancient collisions. They are witnesses. They carry the history of galaxies that passed too close. They move through the gravitational field of the cluster. And their faint combined light may help us trace something far darker than themselves. So the next time you see an image filled with beautiful galaxies, look beyond the bright points. The real story may be hiding in the darkness between them. Because what appears to be empty space could contain a population of stars scattered across millions of light years. And behind their faint glow, an invisible structure that astronomers are still trying to understand. The galaxies may be the brightest things in the picture. But perhaps the space between them is where the most important clues are hiding.